It's likely that you know water is important, but do you really understand just how important it is? If you think about it, our planet is covered with water. Your body is mostly water. In fact, you would only survive a few days without it. But you're not the only one. All living organisms need water to survive. And what makes water special is that it has some very unique thermal properties that help us and everything else on Earth get up and go about our day without even thinking about it. Let's start with the specific heat capacity of water, which is the amount of heat required to raise the temperature of 1 gram of something by 1 degree Celsius, or more generally, the resistance to temperature change. Water has a very high specific heat capacity, so it can absorb a lot of heat with only a small temperature change. This is why coastal areas have more consistent temperatures throughout the year. Large bodies of water absorb and store large amounts of heat from the sun, and as they cool, they release it into the air. This helps protect not only life on land from extreme temperature fluctuations, but also marine life. Water's known specific heat capacity can also help us measure energy changes in chemical reactions. Since we know how much energy it takes to change the temperature of water by 1 degree Celsius, we can use water to measure the change in heat, energy, of a chemical reaction. Water is also special because it has a high melting point and boiling point. 0 degrees Celsius or 32 degrees Fahrenheit is the melting point. 100 degrees Celsius or 212 degrees Fahrenheit is the boiling point. As a quick reminder, the melting point is the temperature at which a solid becomes a liquid, and the boiling point is the temperature at which a liquid becomes a gas. Water isn't a very heavy molecule, so you might think that it would melt and boil easily. Not the case. Water's hydrogen bonds hold molecules together very tightly, making it difficult to break them apart. The melting point of a substance is also its freezing point, because this is where the phase change occurs in both directions. And this leads us to our next thermal property of water, its density. This is the amount of stuff packed into a given amount of space. Density itself isn't necessarily a thermal property, but because it changes with temperature and phase, because water's density is so unique, we need to cover it here. Most substances become more dense as they cool, because their molecules are slowing down and condensing together. Water has its own ideas about this, though. Believe it or not, water actually becomes less dense as it cools. As water cools, instead of moving closer together, the molecules hold each other at arm's length with those hydrogen bonds and create a nice crystalline structure. This also explains why ice floats on top of liquid water. It's less dense. The importance of this cannot be understated, because this property of water is what allows life on Earth to survive. If ice was more dense than liquid water, it would sink, and all the water would eventually freeze and become ice as well, killing all the life in the lakes and oceans. However, since ice floats, it creates a blanket on the surface that insulates the water below and keeps it from freezing. This allows life to go on underneath the blanket as if nothing happened. Related to the water's specific heat capacity and its melting and boiling points are the heat of fusion and the heat of vaporization. Melting is also referred to as fusion, so the heat of fusion is the amount of energy required to turn a solid into a liquid. Likewise, since vaporization occurs when a liquid turns into a gas, the heat of vaporization is the amount of energy required to turn a liquid into a gas. For water, these values are 334 joules per gram and 2,256 joules per gram, respectively. We already know that water can absorb a lot of heat before it changes temperature. But what's important about the heat it absorbs is when all that stored heat gets released somewhere else. This is what happens when heat stored in water bodies vaporizes into the air in places like the tropics, and then gets transported to other parts of the world. When that warm water vapor reaches a cooler area, it condenses back into liquid form and releases some of that heat, helping to stabilize temperatures on Earth. So, let's review. It's safe to start by saying that it's clear that water is amazing. Its many unique properties support life on Earth in a number of ways. The hydrogen bonds that hold water molecules together are responsible for many of its properties, including its high specific heat capacity, or the ability to resist temperature change, its high melting point, which is when a solid turns to liquid, and boiling point, which is when a liquid turns to gas, and the amount of energy it takes to melt and boil water, its heat of fusion, and heat of vaporization. Water's density, the amount of stuff packed into a given amount of space, is also important, because this property is what allows life to exist on Earth. Frozen water is less dense than liquid water, which means it floats. This in turn allows aquatic life to survive during cold winters, instead of freezing up like popsicles.